All right, hey guys, I'm going to be solving number 25 from practice exam number 2 by request. So the problem says f and g are differentiable functions such that f is the integral of g. And before we go any further, I think it should be worth mentioning that I just know this is going to come into play in the problem, right? Big F prime just is g, right? By the fundamental theorem of calculus. So then we're also told that f of a and f of b are both 3, and that B comes after A. Which of these multiple choice options could possibly be the solution? So let's head to the board and let's see if we can't make it happen. Okay. Bear with me for 1 second. Okay, so in the little window, you're still seeing the problem, I'm hoping. And in the big window, you're seeing my work at the whiteboard. Okay, so let's hop to it. Hopefully you can hear me, see me okay. And so we're going to do this problem together real quick. So like I said, the first thing I'm going to say about this is that f prime, honestly, this is one of the key insights a lot of times to these problems, just is g, right? And then it says, well, let's start kind of thinking about some of these options. We'll go right for the option that seems best for us. I'm going to just graph a possible picture of f first. Off to the side, here's a picture of big F. A, B, both of which are bigger than 0. B is bigger than A. So we're told that f of A and f of B are both 3. Okay, so what does f look like? Well, I don't know. It could look like all sorts of things, something, right? So now let's start asking, look at some of the options here. A, it says g of x is 0 for some x such that x is in between here and here. So is it possible that there's some place where g is 0? But what do we mean by g? Oh, that's right. We mean, is there some place, just replace on all of these multiple choice answers, whenever it says g, just write like f prime, right? So is it possible, let's read A again, is it possible that at some place, or rather, can we guarantee that at some place, big F prime, the derivative of this picture I just drew, is definitely 0? And the answer is by the mean value theorem, or by Rolle's theorem. We definitely know that no matter what we draw in between here, if this is differentiable the whole time and all that, then no matter what path we draw, that the average rate of change here is 0. And so we've got to just get a slope of 0 somewhere. We're guaranteed A. So I think the answer is already A, and we're done. But let's just go through and check the other ones and say why they're wrong. For B, it says g of x is equal to 0 for all values in between. Well, that's saying too much. We can't guarantee that it's a flat line in between. If it looks like this, you can see there's definitely some places where the derivative is 0, but we can't guarantee that for all values in between here and here that it's going to be a flat line, the derivative. Remember, I'm replacing each g by f prime in my mind as I'm saying it. And then for C, why is that wrong? G of x is greater than 0. Is the derivative always positive, is what this is asking, for all values? No, definitely not. We can draw plenty of pictures. And what this is saying is it would have to be like definitely true. And it's not definitely true. In fact, I don't think you can draw a picture like that. And then the last one, F, now it refers to actually this picture is greater than or equal to 0. Well, actually, I kind of already read the answers ahead of time, and I already knew this one was coming. So I intentionally drew one where F drops below the x-axis. Could that happen? The answer is, of course, it could happen. Could it be? It says here, can we guarantee that F is always greater than or equal to 0 for all x in this interval? And the answer is, of course, we can't guarantee that. It could certainly be that that's the case, but we can't guarantee that that's true. It says, which of the following must be true? A.